Hey, this is Mr. Ward, and I'm going to do a key for Do Now 18.2, week 18, day 2. So here we go. So I've changed out this Do Now a little bit so you're not doing lengthy proofs and so forth, because I'd like to give you more time in class to move through the chapters, but I did want to get you thinking about some things about proofs. So do the givens in this proof question give us enough to directly prove the conclusion that angle WQP is congruent to angle XQP? Why or why not? So let's identify the angle that's in question. This WQP and XQP, that's the angles that we're looking at, okay? This angle and this angle, they're actually adjacent, okay? So that's a little messy. Let me do that again. So we're looking at this angle and this angle. Are they congruent, right? And we're trying to prove that. Okay, do we have enough information? Well, we're told PQ bisects YZ, which is why we get this marks here and here, which tell us that ZP and YP are congruent. We are told that Q is the midpoint of WX, which also tells us that WQ is congruent to XQ. We're told that angle Y is congruent to angle Z. So there it is. Those are marked. And we're told that WZ is congruent to XY. All right. Do we have enough information to prove that these two angles are congruent? Well, to do that, we would need to prove that this triangle and this triangle are congruent. And then we could do that. Let's see. We've got side and side. We've got this side being congruent to itself. We could prove that. But we would then need, well, this side and this side, this side and this side is not enough right by themselves. We would need an angle. We're trying to prove that angle, or we would need another side. We don't have that third side yet. So we cannot prove directly with the information that we have. We need at least one more detail about the triangles WQP and XQP. If we had sides WP and XP, as if we knew that they were congruent, if we had this, then we could prove we could use side, side, side to prove triangle WQP is congruent to triangle, let's see, XQP. If we had that, so if we had this side and this side, we could prove that, but we don't yet have that. So we're going to have to do a little bit more work. So let's take a look at the actual proof for this. And I have left out a reason. So you want to read through this proof with a conclusion from 1A at the top. So you may have noticed a missing reason for statement 6. What reason should be given for the statement that WP is congruent to PX? Which is in fact what we need, WP and XP. We need to be able to prove that. So what is missing? So let's see what we've got. We got our given. We can then prove that ZP and YP are congruent, because if a line bisects a segment, it divides the segment into two segments. We were given angle Z and Y as congruent. We were given WZ and WY as congruent. And then we can prove that triangles ZWP and YXP, so ZWP and YXP, we can prove that you may have already noticed that side angle side will allow us to prove those triangles. So then the thing goes on and says WP is congruent to PX. Well, what reason could it give that WP is congruent to XP? Well, the reason is that those are corresponding parts of congruent triangles. So the reason would be Kappa-Kadaka, because P and XP are corresponding parts of the two triangles that were just proven to be congruent by side angle side. Okay, so in regular life, a detour is an alternate route you take if there's something blocking your way, a construction or a traffic jam. Well, why does this proof take a detour? What does that allow? Well, it takes a detour because we didn't have enough information to directly prove what we wanted to prove. We needed these sides. And by taking a detour and proving these triangles were congruent, that gave us the information that we needed. Okay, so my first step was to take a look at the conclusions and see what I might need to prove that. And I quickly figured out I didn't have enough information to prove that directly. So I need to do a little detour, a side trip over to these triangles, ZWP and YXP, and prove that they're congruent so that I could prove these parts, WP and XP, are congruent. Once I have that information, then I can prove that these two triangles are congruent by side, side, side. I will have to say PQ is congruent to itself by reflexive. We've already been given that Q is the midpoint, so we can then state WQ and XQ are congruent by definition of a midpoint. But we needed this third side. Once we've got that third side, then we can prove these two triangles are congruent by side, 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 and then we can prove that these two angles are congruent because they are corresponding parts of congruent triangles. So Kappa-Kadaka. I hope that helped, and I'll spend a little more time on detour problems for folks who are ready for that, and missing diagram problems. I hope that was helpful.